Hi, my name is Michael Berrien. This talk was supposed to be given by Layla Binney. She had some other things happening today, so she asked me to step in last minute. For this project, I really just created the dashboard, and I did some work with the drones and water sampling, like the physical water sampling. So I will try not to butcher all of the research that has been done in this project. But just fair warning, I'm not a water quality person, I guess. I'm more of a drone and GIS person and creating dashboards, but I will do my best. So this project was through the Environmental Enhancement Grant from the Attorney General, and we're assessing water quality in lakes in North Carolina, and our specific area of interest is High Rock Lake. So I'll do an introduction for the project and some of the things that we've done, and then we'll talk about methodology and results, and go from there. Oh, that's fun. My slides are changing. So North Carolina A&T University is the university that I'm a PhD candidate at. We are working with Wake Forest University. They have the grant, and they asked us to help satellite or model satellite imagery to look for chlorophyll A concentrations in High Rock Lake. And then I also worked at North Carolina Central University. North Carolina Central University we created the dashboard and collected all the data and put everything together so the public can see it. We all know how vital water is to our society and to humans, not just for drinking, but recreational. Our technology uses a lot of water, so it's important for us to keep that quality standard high. The Global HAB report, 43% of phytoplankton. The chlorophyll A causes a big issue with quality, especially in North Carolina. A lot of our lakes have water quality issues. So we are coming up with a monitoring system that is more cost effective and can be used across the whole state without needing a physical person to go there, because that is more expensive. So the project goals was continuing not just High Rock Lake monitoring, but all the lakes in North Carolina for water quality aspects. Creating AI models that can predict what future chlorophyll levels will look like in those lakes. Testing different methods with the satellite imagery to get the best model for the best lake and the best satellite imagery. So not all satellite imagery is the same. In this project, we used PlanetScope and Sentinel-2. And Sentinel-2 is 10 meters, but the PlanetScope data is 3-meter resolution. So different models perform differently for those different images. And then creating a public dashboard where everybody can go and see the water quality of that lake. I don't know how up to date they want that monitoring system to be, but hopefully it would be pretty accurate for the day that you're there. So traditional methods, which we also had to do in conjunction with doing the satellite imagery analysis, is we had to go out and take physical water samples, label them, and take them back to a lab. And that would tell us, like the suspended solids in it, chlorophyll levels, turbidity, a bunch of different things. We also have a WISP, which I have in a later image, that uses I'm trying to think of the word for it. You point at the water, and it tells you the stuff that's in the water from a radiometric standpoint. And then we used the spatial or the temporal and spatial imagery for the lake, depending on the time of year and how it changes throughout the year. This project was mostly between 2022 to now, and it's still going on. But we do have some historical data that gives us some evidence on future predictions also. So we're at High Rock Lake. That was the only lake that we have done our work with so far, and it's really just to prove the model and that the capabilities of using satellite imagery to monitor and identify chlorophyll levels in lakes. You cannot swim at High Rock Lake, but there are houses that are around the lake, and it's mostly used for boating and recreational sports. However, the lake is, I don't even know how to put it, it's more and more shallow. So like whenever we were to take the boat out, we had to go specific routes so we didn't run into land. And there has been a high concentration of chlorophyll A in High Rock in the past, and that's why we chose it as a subject to study. The different, I don't know why this isn't changing. Hold on one second. Okay, so the Sentinel-2 has 13 bands where the PlanetScope only has 8. But the Sentinel-2 has 10-meter resolution, which for water quality is for, the lake's big enough, but it's not, having the smaller resolution really helps identify the impacted areas and gives a better gradient across the lake. But creating a model for each one will let us monitor it more closely. It doesn't want to change now, does it? Oh. There we go. So we use the physical data collection, the INSTU, to test our models whenever we would create them. So we'd go out, we would collect physical samples, send them to the lab, and have those numbers, and then we would take the satellite imagery from the same days that we had collections, and then see, this is where the technical side of things come into, and I wasn't a part of everything. Using the different bands to calculate the levels of chlorophyll in the lake, and then run it into a machine learning model to do future predictions. Okay, this one's not. So this is the WISP that we used. You have to hold it out at a certain angle at the water, and I use radiometrics to identify different wavelengths that are coming from the water. And we use this to also get an accurate chlorophyll A count in the lakes on the days that we did go out. And this is what the lakes would look like. So if it was green, a high chlorophyll level. If it was muddy, which often at the northern part of High Rock Lake is muddy from the Yadkin River coming in, you can tell the difference from satellite imagery, and then knowing the data that's in it, you can create a model based just on the pixels and the color of the lake for that day. So we had to do atmospheric correction for all the satellite imagery, because depending on the day, it could be hazy or cloudy. Then we had to match up all of our samples that we took physically with the satellite imagery, and we could run regression analysis to determine the chlorophyll A levels of the lake for that day, and then we would use those levels to train the models. And these are the results from the different models, utilizing different methods. So for Sentinel-2, let's see, I'm trying to remember which one she said. The XGBoost model was best for using for training the AI model for the chlorophyll A levels versus the predicted, where the Sentinel or the PlanetScope data worked best on the support vector regression. So having the different resolutions means that you have to use the different models. We are working on a data fusion aspect of it so we could have one model, and based on whatever resolution it has, it can work no matter what. But right now, this is where the project is at. Yeah, I didn't do it. All right, and this shows more of the results where Sentinel-2 gives more of a homogeneous result because the pixels are bigger, so it can't identify as accurately where those high concentration levels are. But the PlanetScope gives a much better representation of where there could be high chlorophyll levels. And then versus us going and collecting the samples physically, we're able to see how they correlate in that graph. For the, I want to say the Sentinel-2 was closest to, I don't have my notes. The Sentinel-2 was closest to the Instu data collection, so we were able to use that one the most. Yeah, that's it. So this is a data collection, and I'm on the left side there with the drone, and that was most of my capacity, was drone work and physical samples. And we had a big team over the years. It's changed quite a few times. But we'd go out, we use the WISP and do physical collections with the jars, and those would go back to the lab. Then we use the drone to collect aerial samples to compare those to the satellite imagery. And this is probably where I'll talk the most about, because this is where most of my experience has been, was creating a dashboard for this, for public knowledge on the water quality in High Rock Lake. This is active in ARC. I created it with web experience, but it has all of our data, and then it will have the future data for the prediction models whenever those are available, and any future data collections that we do. And this just shows a rough graph of the different levels of what we thought was most important, which was the chlorophyll, turbidity, and the suspended solids. But we're also adding more information about, there's a youth girls group that works with this team also that does water quality aspect. We're also working with the environmental enhancement grant. They have different environmental justice portions that go into this grant, and it is also on this dashboard. So we're just trying to integrate everything into public information for this project. Did I talk too fast? How long do I have? 8 minutes. Yeah, I don't know if I can talk for 8 minutes. I think I talked too fast. So I don't even know. Do you want to come up and say anything? Because you know more of the radiology or the radiometrics of this. Layla? This is my advisor. She knows more about the science side of it than I do.
Actually, just sorry, we had a defense for a PhD student, so I needed to do the paperwork before coming here, and Michael accepted to help with the presentation. So this project, I think already you mentioned that funded by Attorney General of North Carolina to developing a low-cost UAV-based system that monitor the water kind of lakes. So, and as you know that, like they're variable from one lake to another lake might be changed. So it's very kind of, we have locality and also seasonality in the modeling of the kind of water quality assessment. So this project, basically, we try to see that how we can develop a system that continuously monitor our water kind of lakes using the satellite imagery. They are free data that we can get, and just continuously see the condition of our water, what kind of lakes and water condition. So for this reason, this project basically try to see that if we go with satellite imagery or using the UAV system or using the in situ data, what is the accuracy and like trade-off between accuracy cost and the time that we spend to calculate those water parameter. So for this reason, this project basically we are working with Wake Forest University and Central University that the Wake Forest collect the sample, the kind of water sample. We go out for the data collection campaign that we create synchronized data. That means when we know that when is a overpass for sentinel imagery, we go outside exactly at the same time. So we collect the water sample, and also at the same time we fly a drone, and we try connect them together at a different resolution, multi-resolution. So we see that how's the signature of the water kind of quality is shows, in the lab, we calculate chlorophyll, and also we're looking at how's the reflectance when we're using the radiometer, directly connect closely from the water, and how it look like on UAV data, that our UAV is multi-spectral, that has many bands, and also we're looking at how it looks like in satellite imagery. So we create that multi-resolution model, and then if like right now still we are working on that, but when this model is ready, if something happened during a storm, toxic things go to water, or for any kind of different situation, if we have just satellite imagery, we can reconstruct those variables through that model. So this is the concept. And also another thing, normally in traditional way, we collect data. We're doing kind of a physics model. That means like we develop a physical model and say that, okay, this is the variable is important. So we are doing the feature engineering. We know what variable we are looking for. But in this study also, we try to go with AI approach. And right now we are working on deep learning approach that basically the model directly consider all variable, and even those that we never can recognize or see or consider in our model. So that project basically we are trying to compare different machine learning, and right now we are working on the water quality assessment for Lake Erie, because through EPA environmental through the EPA funding, they have some buoy that is located in water. So, and many sensors that they collect data from, I think, 2011 to right now. Each 15 minutes, they have a value for each parameter. So that we have a lot of rich data set, time series data set, that change over time from kind of 15 years ago until now. So we're going to feed those data to deep learning, and that's going to create a model that how water quality change based on the different activity in the environment. So yes, and the rest of this project also going to be on the how environmental justice, how the activities in the urban area and agriculture and all can all contribute the pollution in the lake, water quality. Do we have time or?
No, I think we're good. So see, I didn't want to butcher everything, so she knew a lot more of the scientific side than I created a dashboard, and I helped collect the data. So, do you have any questions? Yeah.
What spectral bands or indices are you using on the different satellites? I know you were talking about how
Yeah.
Telescope is 13, Sentinel is 8, and we were kind of comparing the different results there. Are you using the same spectral bands from each one, or are you using all of them?
Thank you for that. That's a very good question. Actually, we are using the Sentinel optical. It has, like, I think we're using of 8 band of it. But for UAV, we have RGB and multispectral. We have, red edge and all of the RGB. And yes, we are, in our study, we have looked at the different scenario using exactly same band, and also when the data is available for us, we're trying to see that capability of satellite imagery. So yes, but for UAV, we have just multispectral 5 bands, and we also look at the RGB. And one thing also, I want to say that for satellite imagery is easier because that is cover huge area, but for UAV, data, we had that issue for the creating orthomosaic because in the water, like basically, we have very high resolution data that is hard to stitch, like just finding type point or some kind of point that we can connect those imagery together. But yes, regarding your question, definitely we consider checking exactly same band, and also we went also we check the including other band that is available through satellite imagery. And we have publication on that I would be happy to share with you if you are interested in this work.
What kind of industries surrounding the lake that may be having input into the water quality, and what kind of other analytes and things are you hoping to kind of get from that? Just because North Carolina has a very big focus on PFAS, so is that something else that you guys are going to start sampling for?
Maybe I leave that to you answer,
Yeah.
because he created the dashboard, so all of those features. So
Yeah, so that is what we're, on the dashboard, there's a bunch of different elements that could impact water quality in the lake, around the lake, and actually for most of the state. But we are looking at narrowing down certain impacts from like CAFOs, poultry, cattle, any type of agriculture aspects. And we're also working on the hydrology for the water grade to see where the water is coming from and what impacts that has on it. So we are they're looking at creating an AI also for that, to look at different things that could impact it.
yes, just adding, sorry for adding to that, we also working in my lab in a lot of natural disaster, and one of them is storm and flooding, and we try to see that how the water quality changed because of all of those, flooding. And
I was going to ask, where can I find this dashboard, or is it publicly available yet?
It is publicly available.
do you have links, just showing?
I don't have the link. I could create an QR code in the future. But if you just want to meet with me, I can send you an email with the link in it. Yeah.
Did you find that when you were using drones to capture imagery that it helped like overcome, like say you were sampling on a cloudy day, were you able to maybe when you could use satellite imagery for certain patches, then use drone imagery instead in order to like overcome that barrier?
Yes. So the drones, in my opinion, are very helpful. Satellites are great and they cover a large area, but clouds and there's a lot of impact from weather. Using the drones, the only thing is making an orthomosaic of water is very difficult because all of the tiles look the same. So whenever you're trying to stitch those together and make one image, so we have to use RTK or PPK that's offered through the state to get precise imagery and create those orthomosaics.
Yes, and I would like to comment on your very good question. Actually, satellite and UAV, each of them has some advantage that they can, replace each other. Satellite imagery, especially in the big lake, like Lake Erie, for example, satellite imagery can quickly give an insight what's happening, right? But UAV always is good because you get high resolution data. So, and if you want to do continuous monitoring, global monitoring, always satellite imagery is the best choice. But when we want to study something in detail, definitely drone. So I say like each one has its own advantage, but just we try to also compare to see in terms of accuracy, cost, and different challenges, which technology offer better.
Hey, my name's Chris. I'm with Fayetteville State University.
template, maybe with other bands, for instance, with other things that I'm looking for example, iron, manganese, contamination, water, not contamination, we know it's in all the water, but the levels of them to dissect that. And there's another part that I wanted to get to, which I just forgot, but that's the main question.
Yes, thank you for this question. Actually, when we're talking about remote sensing, we try to see, first of identify the signature of different things, right, through the imagery. We, our lab, kind of my lab is more kind of remote sensing activities, so for different projects. So we are working with the scientists from Wake Forest University and Central University because we wanted to also have domain knowledge about the water quality itself. And we are not expert in chlorophyll or other parameters, but rather we are expert in processing remote sensing to create kind of useful information. In my lab, we are working on the natural disaster like detecting and predicting landslide. Flood, when flood happening, quickly detect the flood kind of an inundation area. And, like just we have the precision agriculture, looking at the, like disease in the crop, even when they are not visible by eyes. So we are working more on method, but definitely for each things, phenomenon or variable, there is a different signature in the imagery. And so we need to identify that and then train a model based on AI and detect that. But also for this project, we're going to work our SAR data, synthetic aperture radar, because each data captures some physical property that maybe is not kind of missing in other data. So data fusion, combining of them, they can provide a complete picture of what's happening. Yes, returning to your question, I'm not expert in water quality, but I assume that it's feasible.
Thank you very much.
Yeah. All right, and that's it. Yeah.
For the in-situ sensor you said you were using, is that like, are you using that to calibrate your model?
Yeah.
To get data from, are you using, is that what you use?
Yeah, we're using the WISP. It's a WISP. It's just a spectrometer. We're using that to make sure that our data is accurate for the models.
And we collect also water sample and take to lab and calculate, kind of estimate all of those variables.
And that's one sensor for volume,
Yeah.
not a network.
Yeah. All right. Why is this not showing up?
Thank you.
Yeah, thank you. Yeah.